Let's talk about the price elasticity of demand. This is a really important concept for us, so let's get into it. What we're talking about is a measure of the responsiveness of the quantity demanded to the price, and it's a very important relationship. What we're asking is, when the price rises, does the quantity demanded fall a little or does it fall a lot? One way to get some intuitive understanding of this is to think of a kind of extreme example. So this is insulin over here. For diabetics, it's pretty darn important to have this stuff. And here's salt, which is pretty darn important for everyone to consume. Without it, bad things happen. And so if we were to ask the question, how responsive is the quantity of these products demanded to the price? Well, because you need them to live, the quantity would fall only a little if the price were to rise. And if we think about what that looks like in a demand curve diagram, it's a demand curve that's, nearly vertical. That's a pretty inelastic demand curve in most of the relevant price ranges. Elasticity is our actual way of measuring the responsiveness of the quantity demanded to the price. So the way we define the price elasticity of demand is as the percent change in quantity with a percent change in price. So we're asking something like, if the price were to rise by 1%, by what percentage would the quantity demanded decline? And we're talking about along the demand curve. So we can calculate price elasticities of demand, and we do it using this formula. So it looks a little bit imposing at first, but it's not too bad. So what we're saying is this thing we call epsilon, and I guess if we're being strict about it, epsilon of Q comma P, because it's the responsiveness of quantity to price. Well, we calculate that as delta Q over Q, which is the change in Q divided by Q, so that's the percent change in Q, all over delta P over P, which you could think of as the percent change in price. If we rearrange that a little bit, we get delta Q over delta P times P over Q. Now, a couple points to make. One is, although it's related to the slope of the demand curve, it's not the same as the slope. The second point, I'll talk a little bit more about that in a moment. Second point to make is that various ranges of the elasticity of demand, the price elasticity of demand, have names. If the elasticity is less than -1, so therefore a number like -2 or something, we call it elastic. If the elasticity is -1 exactly, we call it unit elastic. And if the elasticity is between 0 and -1, we refer to it as, quote, inelastic. So these ranges are illustrated kind of pictorially here. We see a number line which goes from 0 and then to the left to -1 and so forth. And so this range, less than -1 is elastic, -1 unit elastic. The range between -1 and 0 is inelastic. And if we want to think about what those ranges mean, over on the left, when it's elastic, the quantity demanded is highly responsive to price. And so you could think intuitively of a demand curve that looks like this. Whereas over on the right, where we're inelastic, the quantity demanded is not very responsive to price. So the intuitive picture in your head is something more like that, almost vertical. Now, what is it that determines elasticity of demand intuitively, and when you think about the economics of the situation? Well, the first thing is the availability of substitutes. That has a big effect on the price elasticity of demand. If you think about a really narrow product, a narrow category like asparagus, ask yourself the question, are there any substitutes for asparagus? And if your goal is to consume some vegetables, yes, there are, because there are many other vegetables besides asparagus. So because there are lots of substitutes for asparagus, we would think the demand would be pretty elastic. If we get to a broader category like all vegetables, well, now the question is, are there really good substitutes for vegetables generally? Well, kind of, but not really. I mean, there are some substitutes for vegetables. You could take vitamins, or you could just eat grain. But really, there aren't great substitutes for vegetables as a category. So we would think about this one as being less elastic than the demand for asparagus in particular. Finally, think of an even broader category like all food. Well, is there any substitute for food? Not really. I mean, if you don't eat food, then eventually you'll die. So the demand for food generally is going to be pretty inelastic. So the big point here is that as we go from very narrow categories to very broad categories, the elasticity goes from elastic more toward inelastic. The time horizon in question also matters for the elasticity of demand. Think about what happens when you come upon a price of gasoline that's pretty high. What can you do in the short run versus the long run? Well, it takes some time to respond. You already have whatever vehicle you own. Maybe you could drive it a little bit less in the short run. Maybe you could take the bus. In the longer run, however, you could make a much bigger adjustment. Like you could get a more fuel-efficient car. You could trade in your old gas-guzzling vehicle for a new, more fuel-efficient vehicle. And if a bunch of people did that, the demand in the long run would be much more price elastic than in the short run. So when we say time horizon matters for elasticity, and we want to put this into pictorial, intuitive terms, we could think of the short run as being pretty inelastic, and the longer run as being more elastic. We often work problems with linear demand curves, and so let's talk about what happens to the price elasticity of demand along a linear demand curve, and it turns out that it varies. So let's take this pretty simple example of P equals 10 minus Q, which is also known as Q equals 10 minus P. So what's going on with this one? Well, first of all, the elasticity formula, which we saw a few slides ago, was that epsilon equals delta Q over delta P times P over Q. The next question we can ask, really step one in this problem, is to find delta Q over delta P. Well, what is that for this demand curve? Well, this is the change in Q when P rises by 1. And with this demand curve, if P were to rise by 1, Q would fall by 1, so delta Q over delta P is equal to negative 1. So we could write the formula, and we're not quite done yet, by the way, but we could write it as minus 1 times P over Q. If we want to express that entirely in terms of P, we could write it as minus 1 times P over 10 minus P. Where'd I get that? Well, that Q is just equal to 10 minus P from the top of the slide. Or if we wanted to express it solely in terms of Q, we could express it as minus 1 times 10 minus Q over Q. Now, where'd I get that? Well, the numerator there, the 10 minus Q in parentheses, is from the top of the slide. That's what P equals. But notice here that the elasticity on a linear demand curve depends on where we are on the curve. It's not just a particular number, it's a number that varies depending on what price-quantity combination we're at. So let's talk about step 2 here. So we've got this formula. One of the formulas we had above, the one in terms of P, was minus 1 times P over 10 minus P. So, and there's a picture of the demand curve over on the right. Anyways, what's the consequence? Well, let's think about a couple of particular price-quantity combinations. For example, at a price of 4, the quantity is equal to 6, because that's just what you get plugging into the demand curve. But that means the elasticity at a price equal to 4 is minus 4 over 10 minus 4, or 6. So it's minus 4 over 6, or minus 2/3. And that's, as you'll recall, an inelastic range of the demand curve. Whereas at a price of 8, the quantity is equal to 2. There, at a price of 8, the elasticity equals minus 8 over 2, or minus 4, which is elastic. All right, what are the takeaways? Well, first, the price elasticity of demand is a unit-free measure of the responsiveness of the quantity demanded to the price. The exact formula for the elasticity, or the price elasticity of demand, is delta Q over delta P times P over Q. Conceptually, we expect demand to be more elastic in the longer run than in the short run. And we also expect demand to be more price elastic for more specific products, such as, say, asparagus, than for broader categories such as all vegetables or food generally, whose demand has to be pretty inelastic because without it we die. Finally, the elasticity of demand is going to vary along a linear demand curve. We usually work with linear curves in this course, so that's a handy thing to remember.